Good morning, friends and colleagues. Our very own Nelson Mandela is said to have once quoted that our children are our greatest treasure. They are our future. Those who abuse them tear at the fabric of our society and weaken our nation. We have an array of gazetted laws and national policies that protect the rights of children. And yet, the startling reality is that more than 1 in 4 children in South Africa, amongst the survey groups, are shown to be stunted due to malnutrition to the extent that it negatively impacts their physical, neurological, and cognitive growth and well-being. Although this is a massive topic, in this brief presentation I will introduce what stunting is and what causes it, what some of our driving national nutritional policies are, why they're important, why we need them, and what evidence was used to inform them. And through all of that, I will provide a critical analysis of how effective these policies are or aren't at an individual level. Stunting is a severe form of growth failure characterized by low height for age development. Although stunting is avoidable, it is irreversible. It can cause delays in physical development, poor cognitive function, and increased lifetime risk on chronic diseases such as type 2 diabetes, cardiovascular and gastrointestinal disease, and some cancers. Stunting is caused by a multifaceted range of factors, not least including poor maternal and infant nutrition, repeated infections from worm and parasite infections causing diarrhea and enteric dysfunction, malaria infection-induced anemia, and inadequate psychosocial stimulation. Nutritionally, vitamin A, iodine, zinc, ferritin iron, and polyunsaturated fats are critical for fetal brain development. South Africa has one of the highest stunting rates in the world. The South African National Income Dynamics surveys over the period 2008 to 2017 assessed a representative spectrum of over 14,000 children under age 5 and found that 27.4% of those were stunted. Survey participants were selected using a systematic random sample in a multi-stage stratified cluster sampling design setting. The study included women 16 years and older who had given birth and focused on self-identified black respondents being representative of 85% of the South African population. Dr. Lawrence Haddad, Executive Director of the Global Alliance for Improved Nutrition, describes malnutrition as a slow violence because of how it causes stunting and critical micronutrient deficiencies which compromise the lifespan health trajectory of children's lives. Malnutrition has grave consequences for children. Micronutrient malnutrition is called the hidden hunger. It is most insidious when it involves a person eating adequate or even excess energy, but with inadequate micronutrient content. Malnutrition can still occur in overfeeding. Our bodies are not just looking for food, they're looking for specific micronutrients that are essential for their chemical structure needed by our various tissue cells. Pregnancy and the mother's diet are the most crucial factors in a child's development. The origins of chronic lifetime disease risk and our metabolic set points are coded into our DNA in utero. A child's DNA is encoded in the mother's egg, defined by what the child's grandmother ate. There's a 3-generational link between the grandmother, the mother, and the eggs the mother will fertilize to birth the 3rd generation lineage. Excess glucose consumption during pregnancy can be harmful to fetal development, risking overgrowth leading to fetal macrosomia. Excess glucose is toxic to a developing embryo before the early morula stage of embryonic development. Low glycemic index diets, high in fiber, help to improve plasma lipid profiles, whilst high GI diets rich in rice, white bread and potatoes, which are the staple of third world eating, can contribute to fetal overgrowth. hyperglycemia and diabetes are teratogenic, i.e. they're toxic to a developing embryo, with cardiovascular system defects particularly at risk. Heart defects can be twice as high with diabetics than non-diabetic mothers. A high saturated fat diet can cause growth restriction. Maternal high-fat diets can be detrimental to conception, to mitochondrial function of the developing embryos, and can risk preeclampsia for the mother. All of these factors create the environment for a diabetic phenotype. Vitamin A, iron, iodine, and folate deficiencies are common, yet are essential for fetal growth. Iron is the leading single nutrient deficiency, which is key for hemoglobin and enzymatic processes. It's an important regulator of gene expression and is critical for cell growth and differentiation. Excess vitamin A, however, can be harmful, impacting cell differentiation, causing spontaneous abortion, and causing congenital malformations. The range of B vitamins act as coenzymes in several pathways for protein, fat, and carbohydrate metabolism. Vitamin B12 is essential for DNA methylation, and deficiencies can impact cellular growth and nervous tissue development. Vitamin C and E work together to promote oxidative defense, whilst vitamin E is also important for collagen synthesis and promotes iron uptake and absorption. Maternal vitamin D status is critical to improve placentation and conception. Insufficient protein consumption over the gestation period can result in reduced weight and length babies at birth. Protein quality is critical both before and during pregnancy. Methionine, threonine, and glycine amino acids are specifically needed for stem cell growth. Iodine deficiency is the most common cause of preventable mild to severe brain and cognitive impairment, also needed for thyroid hormone biosynthesis. Iodine deficiency can lead to cretinism. Zinc deficiency can also impair growth, immune function, and brain development, whilst the consumption of polyunsaturated omega-3 fatty acids, particularly EPA and DHA, are also crucial for brain development. Inadequate calcium intake negatively affects birth weight, risk of preterm delivery, and blood pressure control. There's an interesting hypothesis by Professor David Barker, known as the Barker hypothesis, that relates low birth weight to chronic lifetime risk of adult disease and obesity. And then also the Helsinki birth cohort study reported how slow fetal development followed by accelerated weight gain in childhood is correlated to coronary heart disease and type 2 diabetes risk later in life. In driving protective mechanisms against malnutrition, we have the National Food and Nutrition Security Plan for South Africa, which is embedded in Section 26 and 27 of the South African Constitutional Law. The policy defines nutrition and food security as access to and control over the physical, social, and economic means to ensure sufficient, safe, and nutritious food at all times for all South Africans in order to meet the dietary requirements for a healthy life. In the Stats South Africa General Household Survey of 2021, it is reported that almost 700,000 households with children aged 5 years or younger reported experiencing hunger. Children who do not have adequate nutritious food cannot develop as they should and are at a higher risk of acute malnutrition. Supporting that nutrition security plan are our South African food-based dietary guidelines. These were first published in 2003, with a revised version released in 2012. Developed by the Nutrition Society of South Africa, these predominantly target people aged 5 years and older, although a pediatric guide targets children from birth to 5 years. One of the principles in designing food-based guideline messages for a specific country or region is that the guidelines should address existing public health problems. To revise the guidelines, the Medical Research Council's Comparative Risk Assessment for South Africa, published in 2007, was used to re-evaluate the appropriateness of them. The assessment was based on the underlying causes of premature mortality and morbidity observed in South Africa in 2000. In nationally representative studies on children by both the South African Vitamin A Consultative Group and the National Food Consumption Survey, high levels of stunting were shown correlated to dietary intake confined to a relatively narrow range of foods of low micronutrient density. Whilst requirements were seen to be met for protein and macronutrients in general, inadequate intakes were reported for vitamins A, B, C, calcium, iron and zinc. In 2003, regulations for the mandatory fortification of all maize meal and wheat flour with vitamin A, vitamin B, iron and zinc were introduced. A randomized intervention trial was conducted thereafter in the Northwest Province to evaluate the effectiveness of vitamin-fortified maize meal in improving the nutritional status of 1 to 5 year old malnourished children. Despite the small sample size, after 12 months the study showed that fortified maize meal could significantly improve weight gain in children in the experimental group. The first 1,000 days of life, from conception to the child's second birthday, lay the foundation for optimum health, growth and neurodevelopment. Those 1,000 days are a period of rapid brain growth and development that is a period of life with the greatest developmental plasticity, where the infant's developing body and brain are particularly sensitive to their environment. In a government survey of KwaZulu-Natal rural children, 40% of the children had low vitamin A status, 28% were anemic, 97% were iodine deficient, and 21% had visible or palpable goiter, which is an enlargement of the thyroid gland due to iodine insufficiency. The survey report highlights that, thus, for most micronutrients, there are a monotony of foods which make up the bulk of contributions to nutrient intakes. There is an urgent need to improve the dietary intake range of children in South Africa in line with the food-based dietary guidelines. In conclusion, nutritional recommendations and national policies are essential for providing minimum frameworks of health and well-being at population-level application. We need these policies because they shape the foundation of adequacy that is founded upon competent scientific research and follow-up surveys. The South African national policies for food security, malnutrition and related adolescent stunting are well-founded, clearly defined and regularly audited via surveys. They're good frameworks in principle, even if they lack the finer definition and detail we might hope they would enforce. The critical period for minimizing stunting risk is in utero and in the first 2 years of life. Nutritional policy recommendations to address this syndrome are thus centered in encouraging awareness of good maternal micronutrient nutrition, encouraging exclusive breastfeeding for the first 6 months of life, and addressing the nutritional adequacy of complementary feeding from 6 months to 2 years of age. Food security, malnutrition and stunting are complex, interwoven, multifactorial challenges that are not easily resolved. They're not complicated because we know what we need to do in order to alleviate them, but they are complex. Government are doing a good job in defining governing policies, but much is needed at grassroots level to ensure adequate application of these population level policies to ensure individual level nutritional needs of our children. Our children are our greatest treasure. They are the future of our nation. They deserve nothing less from us than good governance that gives them hope and opportunity for a prosperous and healthy future. Thank you.